Good afternoon, everyone, and thank you for joining us. This is Sarah Davison with Viavi Solutions Marketing. I want to thank you all for joining us today on our call over the special features of the 8800SX. I have just a few housekeeping notes to share with you. This webinar is being recorded and will be available for you in approximately 24 to 48 hours, and an email to all attendees with a link with the recorded version will be sent out. All lines are on mute, but we are monitoring the chat and will answer questions at the end of the webinar or reach out to you individually to ensure you get the answers you seek. And now I'd like to turn it over to our speaker today, Mike Fortna.
Hello, everyone. Thanks for joining us today. Again, this is a presentation is going to go over some of the special features of the 8800SX. Again, I'm Mike Fortna, and joining me today will be Bill Nichols and Dave Hansons. We're all solutions engineers with Viavi Radio Test Set Division. So we can answer any questions you may have at the conclusion of this webinar. Some things that we hope you'll learn from this presentation: how to use the 8800SX in a fast and efficient way. There's different ways you can use this instrument, different ways you can organize the screens. So hopefully we're hoping to show some of those ways. How to use frequency lists to speed up manual testing. How to do some quick go, no-go testing. And we'll cover some of the optional features that enhance the testing capabilities. So again, fast and manual testing. There's a fast frequency find feature that we'll look at. Color-coded meters. There's frequency lists. We have a fast way to transition from one screen setup to another screen setup. There's automated testing. There's an inline power meter that has some special features, unique features. Antenna sweeps. So all of these things combined really speed up site and or subscriber testing. So presets, you can see we start out with a blank screen. You can configure screens any way you like. And then you can save screen configurations into what we call presets, so which is just an arrangement of tools on the screen. So I'm going to configure the tests for a analog testing. So that quickly populated the screen from a blank screen to all the tools that I would want to use to test an analog radio. Most radios are aligned in an analog mode, but they're tested in a digital mode. So it's nice to be able to transition from an analog configuration to a digital configuration. So here it's going to recall a completely different tool set for testing a Project 25 type radio. Now all the tools are different, and we'll turn on the generator to see some of these different tools. And one thing you can see when the generator came on is that we have color-coded meters. So green's good, red means it's too high, blue means it's too low. So you can actually configure colors of any meter. You have tools that stack on top of each other. This is a huge feature because you can stack many tools on top of each other and then just go back and forth between them. And then you'll notice that a lot of these tools or features are readily accessible. We're going to go back to a preset for analog. So it's going to transition from that digital preset back to an analog preset. And one thing that's kind of different about this product is if you see a tool that you want to change or any setting, you can directly access that setting. So I kind of call that direct access to controls. So like here, we'll change the DMOD type. You see it, you touch it, and change it. So you don't have to find the control. If you see it on the screen, you can just directly access it and change its content. And it is a resistive touch display. So at any time, you can just touch the screen and change whatever item you want. So there were some examples. Here we'll turn on the generator again, turn on the modulator. So there's no levels of menus to go through to find the control and change it. It's just right there. There's a numeric entry. I can just change generate level, hit the enter key. There's also graphical tools, slider bars and things like that to change things like level and frequency. So one really nice feature in this product is the frequency find feature. This will work for analog, Project 25, NXDN, but when power is keyed up, you can press the frequency find button and the receiver will search and find the transmit signal. There is a configuration for that. So we can configure the frequency find and we can enter a start frequency and a stop frequency for the find. If you're just always working in one band, you can narrow that up so that it'll find it faster. But a full band search takes about 6 seconds, and a narrow search like this probably take less than 2 seconds to find a transmit signal. So here we've keyed the transmitter again and we hit frequency find, and there it is on channel. And it doesn't matter where you start. I can move this frequency down to 100 megahertz and hit frequency find again. I'll key the transmitter, hit frequency find, and it's found it in less than 2 seconds. So that is a really powerful feature for testing a subscriber radio or even repeaters or base stations. It can be done off the air. So it's going to find the strongest signal that is above the threshold that's specified. So that makes testing really quick. There's a lock function on the receiver tile that will lock the generator frequency to the receiver frequency. And you can include an offset there. If there's a 5 or 45 meg offset, it would track the received frequency plus whatever offset is entered. Another thing that's a unique feature in this product is the frequency list. So there's a frequency list, and you can store these in directories. You can make directories of different frequency lists, store as many frequency lists as you like, and each list contains a minimum of 100 frequencies. And each frequency, and it's a frequency pairs. So here we've selected a particular list, and each frequency can have a label, so it'll be the same way they're labeled in your radio. So you can choose an index number or a label and hit next, change your radio, key it up on the next frequency. So by using this list, this is actually like a subscriber radio that's in test mode. And in test mode, I can just switch the channel on the radio to the next channel, and I hit next, and it's changed my generate and receive frequencies, and they are offset from each other. So it's very useful. It's especially useful in a site configuration, even if you only had, say, 5 base stations on a site. You find yourself going back and forth between channels, between testing transmitter and receiver. And if you have those entered into a frequency list, you just hit next and previous, or do a direct selection of which channel you want to test, and it just speeds the testing tremendously. So there it's up to channel 8. These lists are also stored as CSV files, so they can be modified in Excel. You can save them in the instrument. You can copy the file from the instrument to a flash drive. You could modify it in Excel. A lot of people already have their frequencies in a list in a spreadsheet. You can actually just take those frequencies and labels and paste them into the spreadsheet and import those back into the test set, and away you go. So as far as some of the digital measurements, here's a digital DMOD tile that has a modulation fidelity. There's graphics like distribution plots. Also, there's an eye diagram, which will bring that up. And these tools can show different types of signal impairments. In addition to the eye diagram, there's also a constellation plot. This is like looking at the distribution plot, but from the top down. But all the visual aids aid in telling you if the radio's in good shape or if there's an alignment issue. There's a channel analyzer that was stacked below that measurement panel. And then there's digital information is also decoded and displayed. So there's things like the NAC code, algorithm ID tells whether it's encrypted or not. And again, we have the color-coded meters for mod fidelity, symbol deviation, bit error. Those are probably the primary type measurements that we would use. And then to test a receiver, there's a digital encode tile where you can use different patterns and other information like the NAC code to open up the receiver for testing. So those are all different tools that you might use to test a digital transmitter and receiver. There's a digital record and playback feature. It'll allow you to key a transmitter and you can record, you can speak into your transmitter and record that audio, and it'll save this automatically as a file. It'll save it for each different digital technology as well. So it'll save a recording for Project 25. It'll save separately a recording for NXDN or DMR. Any of the different digital technologies will have their own recorded. Now, it records signals at a bit level. So that means even if the signal is encrypted, it'll record it that way and play it back, and the radio will decrypt it. There are some organizations that may change their encryption keys on a monthly basis even, and you can record a radio that had been keyed and then play that same recording into other radios, and if they play it, then they've been rekeyed, and if they don't, then they haven't. So it's a quick check to do that. So you can record it once and play it many times. For automated test, the 8800 supports one of the largest libraries of automated test applications on the market. There's a list that keeps growing. So the auto tests are OEM certified with fast results. And each application, like in this example, says Motorola APX, but it covers most every APX radio that's in the list. So there's a test mode and there's an align and test mode. The test mode, when you run that, it's going to go through and perform all of the tests that and at all the different frequencies that would prove that this radio is in good operation order. So most different manufacturers of radios have some group of frequencies that an alignment is done at. So those are our test frequencies. So after the test is complete, it records all the information from the radio. And in this case, this test took in real time was about 3 minutes and 41 seconds. So it provides a full document of all of the information. And you can see on this, hopefully you can see this well, but it records not only the information on the radio, but it records the test equipment also, the serial number, the time and date, shows this version of the application, it shows the software and firmware versions in the radio, and the feature set, and all of that is a part of this test report. One unique feature is an inline power meter, which is over here. It's an option, but it's good for up to 500 watts at 4% accuracy. You can use this for site or subscriber antenna testing as well. In this case, I show it hooked up to a portable radio with an antenna connected to the output. And we can see it's showing a good VSWR match. Shows forward power, it'll show a reflected power, it'll show VSWR match, and it can also show return loss. So this is an example of a good match. And this can be kind of an important test, especially with today's multi-band antennas. You could, maybe the antenna is good in one band, but not good in another. You can also change the duty cycle on this power meter. We'll change it to 50% here. You do that to test like a TDMA type signal, like a DMR transmitter or Project 25 Phase 2. So you can, since TDMA, like DMR, is transmitting half the time, 30 millisecond power bursts, the duty cycle of 50% allows it to measure that power properly. Now we're going to see what it looks like with a mismatch. So we key up the transmitter off frequency, and we can see the VSWR is 11, which is very high. If I change that to return loss, this would be a low return loss because it is a mismatch. For return loss, the bigger the number, the better the match. So we could clearly see that with this radio would not match up with that antenna. So could even have an adapter on the output to put a subscriber antenna on the output, and maybe you've just auto-tested the radio. So you've done an automated test, an automated alignment, and then maybe as a last step before you put the antenna back on the radio and hand it to someone, maybe you test the antenna with this through-line power meter and make sure that the antenna is actually a good match for that particular radio. This is a precision distance default VSWR kit. Here you see this is a return loss bridge. It's used to do measure return loss or VSWR sweeps, used along with the tracking generator. This device here is a power divider. We use that part to do a distance default plot. Then there's a precision 50 ohm load, which is used for calibration purposes. So if you have that, we're going to do a full band sweep on an antenna, and you actually you can enter a start and stop frequency. And to calibrate it, this picture actually shows an antenna connected right now, but you actually do this calibration with the antenna removed, and it'll zero out all of the loss of your test cables, and there's some inherent insertion loss associated with a return loss bridge. So after you've hit the set reference, you'll see you have a 0 dB reference line, so it's zeroed everything out. Now the antenna is connected, and wherever the trace is the lowest is where the antenna is resonant. There's up to 6 markers that can be enabled and turned on. And since it's a touch screen, you can actually just touch a marker with your finger, move it anywhere you want on the display. And here we'll use a mouse. There's also marker peak and min search features that can be used to find the lowest point or the highest point on the screen. So we can also change this from return loss to VSWR, and I can change the scale factor from 2 to 1 here and kind of magnify that. So we can really see that this particular antenna is tuned to the higher frequency 800 band. So that's at this frequency up here is where that antenna would radiate the signal best. It's going to reflect lower frequency signals back to the transmitter. So it's a good way to test your antenna to see where it's tuned to. So if that return loss sweep did reveal an issue, you could do a distance default sweep using the power divider. Again, the calibration is done with no connection. You actually have a 50 ohm term on the power divider and you calibrate it. And then you connect the antenna and you can use the markers. And here we can use a peak search and it shows that that transmission line is 12.399 feet. If there were significant faults, those would show up in between. But what's really nice about this distance default plot is it gives a very fast refresh rate. It's like 2 seconds per sweep. So that if things are changing, like the wind's blowing the antenna or something like that, you would actually see things moving around on that plot. The sensitive spectrum analyzer is a very useful tool for interference testing. We specify a -140 noise floor. You'll actually see it down to -150. But it's a nice tool for measuring for interference signals. There's also a power bandwidth measurement. You'll see a couple of white markers at the top. You can change the width and it'll measure the power between those two markers. So on a digital signal, it'll appear at least 10 dB lower on the analyzer than what its actual power level really is. So you can use that feature to take measurements. I've actually used that measurement function to test digital signal generators down to -138 dBm, and it just tracks it all the way down. So it's a very powerful feature in itself. You can also offset these markers, so you could measure power in an adjacent channel. So that's another measurement you can make with that. So this is the product, itself, better picture, and then this is a case that's available for it, and it holds the return loss bridge, and which can be just connected to it directly without removing it from the pouch. It also has a placeholder for the power divider, so you can just grab the bag and take it on just to the site with you or wherever you need to go. Even if you're auto testing radios in a vehicle even, or a bus or train, whatever, you can just take it with you and hook it up and run those tests. It is battery operated. It runs a good over 3 hours on the battery. The battery's field replaceable. So you can just pop the back off and replace the battery. So we have all that. So in addition to P25, of course, there's other options that are available. There's Project 25, Project 25 Phase 2, DMR, NXDN. There's a DMR repeater test option so that you can test a repeater without having to test it on the air. PTC is positive train control, and ARIB T98 and DPMR or other technologies that are available. And there's many other options that are available for the 8800 SX. As far as software updates, those are always available. We keep for our radio test set products. This is just an example of the 8800's website, but you can download the latest system software, and you can also separately download the latest auto test script software, which is down here. The auto test scripts are updated more frequently than what the system software is, but the system update will always include any of the auto test updates that we have. So with that, that concludes this presentation, and we'll open the lines up for any questions. Actually, Dave and Bill been monitoring questions, and they can answer those or tell us what some of those might be.
Hey, thanks, Mike. There actually were not a lot of questions this time. A couple of questions we may have to get back to somebody on here offline afterward. But there was a question about remote connection to the 8800SX, and that's one of the neat things about the 8800 is that we do have the ability to connect to, oops, let me fix my microphone, sorry. We have the ability to connect to the 8800SX remotely through a VNC viewer, such as Tight VNC, and that lets you drive the unit as if you were sitting in front of it. About the only thing you really can't do with that would be to move cables and that sort of thing. So we do have the ability to do that. The 8800SX does also have a full complement of remote commands. So if you are writing test scripts in LabVIEW or whatever, we can control the unit that way as well in an automated fashion. So there are ways to do that. Of course, you can send commands through Telnet as well if you're doing one command at a time or whatever. So there's, like I said, there are ways that we can do that to control the 8800SX, and that can make it nicer for some people to use it. There's also another question about the frequency list, asking if we're using the frequency list, what happens with the gen offset, and if you have it turned on, you have that gen offset enabled, or the gen frequency locked to the receiver. When we pull up a frequency list in the frequency select window there, and we pull up a particular frequency pair, it does turn off that gen offset lock. So the frequencies will follow what's in the list instead of the that offset that's applied there. So that's another good question there. Let's see here. Like I said, there's a few questions that I'll have to research.
Well, Dave, there was one about bit error testing in DMR for inbound and outbound. And yes, you can. It can measure. You can measure bit error on a transmitter. One of the unique features in the product is a frame sync pattern. So, like in DMR, like a standard test would be to have the radio transmit a 1031 pattern. But if you can't put the radio in that service mode, you can select a frame sync pattern, and you can measure any DMR signal with that pattern. You can measure bit error. You can also generate a 1031 pattern into a receiver to test the receiver. The record playback function, there's a question as to where that is at, and it's on the receiver's button. I don't have don't have a picture to show, but on the utility menu, there's generators and there's receivers. It's one of the items on the receivers menu. But you do have to have a digital mode for that to be visible.
I had a question about running on 220 volts, 50 hertz, and getting correct test results. The AC input voltage range on that is 100 to 250 volts AC, 47 hertz to 63. So you can run your your auto test on 220 without having any problems there.
It'll also run on 12 volts DC off the cigarette lighter.
Yeah, that 12 volt DC is real handy if you're going between sites. You're using your 8800 on battery at one site and you want to charge the battery while you're on your way to the next site. You can plug that into your cigarette lighter and charge the battery. So it's fully charged when you get to your next site. So that is a very handy feature.
I guess these days that's called a power port.
Oh, that's right, power port.
We've got a question here on 2-slot TDMA, like DMR. Will the duty cycle of 50% be correct? The burst ramps up and down, so it's never quite 50%, maybe 46. I believe he's referring to the inline power meter, and yes, you get accurate measurements there, but don't forget that you do have the power profile, power meter profile that you can use too, and it actually has a mask on it, so it will actually measure the burst, the power of the burst, and it will show you the burst, and it's masked off. So if there's anything wrong with the burst and you're outside of the mask, you'll get the mask itself will turn red. So there's a couple of different ways to measure TDMA power, either with the inline power meter at 50% or using the power profile feature in the main analyzer.
Yeah, kind of in addition to that is a direct entry. So if it's 46%, you can enter 46.
Yep.
Also, that power meter is a 4% accurate power meter. So it's a very accurate way to take those types of measurements.
Okay, well, that covers pretty much, like I said, most of the questions there. I think there were a couple others. We'll have to get back to that person offline, but otherwise, great webinar, Mike. Thanks for doing that. If anybody does have other questions that come up after we conclude, please feel free to reach out to us. Be happy to answer those questions, whether it's related to this webinar or not, and help you do what you're trying to do. So thanks for joining us. Sarah, do you have anything you would like to add?
No, that's it. Thank you, everyone.